Should I open or close the tower hot vapor bypass pressure control valve to lower my tower pressure?
Well, that's somewhat of a difficult question. Ordinarily, one would close the hot vapor bypass valve in order to lower the tower pressure. You close the hot vapor bypass valve to lower the tower pressure because that pushes more vapor through the overhead condenser, and that then lowers the temperature in the reflux drum, and the colder temperature in the reflux drum then reduces the vapor pressure of the liquid in the reflux drum, and as the pressure in the reflux drum falls, so does the tower pressure. Ordinarily, we say we control not tower pressures, but we control reflux drum temperatures. However, that is not always true. While it is usual engineering practice to design the overhead condenser for a low delta P, sometimes by error, or by fouling, or by an increase in capacity, the pressure drop through the overhead condenser becomes quite large. Then, when you close the hot vapor bypass, while it is always true, without exception, that this pressure in the reflux drum will fall, it may then happen, again, if the delta P through the overhead condenser is higher than expected, that the delta P in the condenser will go way up, and then tower pressure will then greatly increase. So there is no real correct answer or wrong answer to the question. Sometimes closing the hot vapor bypass valve raises the pressure in the tower, but normally we have the expectation that closing the hot vapor bypass valve would lower the tower pressure.
Norm, should I always keep the water outlet valve on the water cooler wide open to maximize cooling water flow?
Actually, not necessarily so. A lot of our condensers are elevated well above the cooling water return header, so that if you open up this valve 100%, the pressure at P1 falls well below atmospheric pressure. And if the pressure at P1 falls well below atmospheric pressure, then the air that's dissolved in the cooling water, especially if it's seawater, will flash out of solution. And as the airflow flashes out of solution, the volumetric flow through the tubes and the exchangers increases, which increases the pressure drop of the cooling water flowing through the tubes, and that has a tendency to choke off the flow. In order to optimize the position of this valve, you don't actually need a pressure gauge at this point. You would simply look at that valve position that minimizes the cooling water outlet temperature. Now, from experience, at least with seawater, I have found that optimum pressure at P1 is 2 to 3 to 4 inches of mercury, or a slight vacuum. If you throttle on this valve more, the pressure will go up, but then you will indeed restrict the cooling water flow, and then the temperature of the cooling water outlet is also going to go up. Again, as a rough guideline, a pressure of 2 to 3 to 4 inches of mercury vacuum, or minus 1/10 of a bar pressure, is pretty close to the optimum, but that's not my practice. My practice is to optimize the position of this valve based upon the cooling water outlet temperature.